The first 3 weeks of the eruption here in Hawaii, crazy things would happen in the middle of the night. A new fissure would open up and it would threaten a new neighborhood. Thousands of people are evacuated from their homes. I started the Hawaii Tracker Facebook group to help people understand what's going on and get their questions answered.
Hey, how's it going? We're live. This is Fissure 20.
We had hundreds of people all throughout the neighborhoods sending in videos, articles, and images. We spend a lot of time making sure the accurate information gets out.
This is live. There's still lava moving.
They weren't just sharing a story, they were helping their neighbor. If a family was being evacuated, a group would just jump in and help out. So it was huge. They were watching out for each other.
Hello everybody, thank you for coming. Thank you for the support from everybody.
As we go through this, we're growing closer together as a community. When tragedies like this strike, you really realize how much you need each other.
Hello everyone, I'm geologist Philip Ong, here with Mr. Dane DuPont of HawaiiTracker.com, bringing you guys another Hawaiian Volcano Tracker update. Today is Friday, January 6th, 2023, and Kilauea's eruption has resumed for the last 24 hours. There's a new live cam that we're showing you guys here on screen, courtesy of the USGS. Mahalo to those guys. And what we're going to do today is recap the opening sequence of the eruption and the little changes that have occurred, and just talk sorry about that. And by the way, for everyone who's asking, Maunaloa is still quiet and unaffected, but we'll look at that as well a little bit. How are you doing today, Dane? Quiet is the first answer. That's how you're doing.
Oh, sorry about that. Yeah, just looking through all the footage that we've been getting on Hawaii Tracker. Been getting a bunch of high resolution footage, live streams, stuff like that. So big difference from yesterday where we were scrambling to find, anything to be able to share with you. Today we have a lot of different video and angles and all kinds of footage to go through. So kind of excited about that one.
Yeah, cool. Yeah, and of course there's so much that we're kind of picked out the diamonds here of things to show and share and talk about that are educational and help us gain an understanding of the volcano to be better prepared when it does come in some other direction rather than where it is now, which is the best possible place in that summit crater of Maunaloa Kilauea caldera. So yeah, that's the long and short of it is that the eruption is still ongoing. The area of the crater floor that was covered last night was massive. Over 2/3 of that original 300 acres was covered. And it looks like now from the webcam views, let me switch this live view here to the KW camera. Let's see what that looks like. There it is. And maybe let me make this bigger for us here on the screen. Now you can see there that from the KW camera, there's still a big flow along the backside. I'm trying to outline where it still looks like it's red and active right through there. So it's still active on that eastern side of the crater, but less so on this closer to the camera western side. Although we do see that the lava flows from that west vent area have resumed, and that inner persistent lava lake from before has refilled with lava as well. So that's the
that was
the big picture.
That was interesting to see last night that lava lake reemerged from that same spot that it seemed to be doing the crustal overturning, where lava came up first inside that old lava lake.
Yeah, a bit. Yeah, I'd actually noticed, and I was going to save this for later, but there you could actually see in some of the webcam views the old lava tube where the lava would drain out over there in that area.
Oh, wow.
And you could see that this time the lava actually came pouring the opposite direction from the east to the west and filled the pond that way, that from a reverse angle through that same tube, it seemed like. Pretty cool.
A little bit of a teaser for later.
Yeah, we'll have to see how much we can dig into that there. So, but yeah, here's the live view. There's still fountaining happening right now. It seems like the darker areas of the image that you see here are that hardened lava flow crust. So it's all still liquid underneath there, but that surface doesn't appear to be moving very fast, at least. It's hard to tell from just the naked eye to know when this crust is actually moving, let's say like that way or out in this direction. This is why we like to use the time lapses to speed things up and really illustrate what's going on there. So, but if anyone is curious what's happening, if it's still active and still worth going to see, the answer to that is yes. My experience for the last day is that the viewing area at Waldron's Ledge has a really nice angle to see from, but it's the most vulnerable to the mist and the weather that comes in, if that starts coming in at some point overnight. The one at Kanakakoi has the next best view of that whole backside. You can see more of that western side of the crater as well, and less so on the eastern side. So that was really good yesterday, as lava kind of flooded around that western and eastern sides both. But as the flow is kind of retreating to that eastern side now, that northern side of Uikahuna is really catching most of the activity. And I'll show you guys some video from that too. So yeah, that's the current happenings, and we'll catch back up to that. But I'd like to do now is rewind ourselves and go back to, let's start with just let's want to give a teaser as the earthquake map that we have for the last, wrong earthquake map. Well, we'll do the updates here. Oh, there's the earthquake map. This is the earthquake map from last week for Kilauea. For the last 1 week of earthquakes from today. So you see here is that there's a big cluster around the summit area. The blue ones down here in the corner, that's Pahala, the deep ones, so we don't have to worry about those. These ones over here in this area, this is all south flank. That's normal background as well. What's really unusual is the concentration and abundance of earthquakes in the summit region. Not so much that you have them, but most of these were in the last few days. And you have one deeper one here. This is the big green one. It's an adjustment between Maunaloa and Kilauea both. So that's kind of just setting the scene here, setting the stage. Going back to the updates, back on December 30th, USGS put out an information statement, because at that point, 6 p.m. Friday, December 30th, there had been a swarm of approximately 25 earthquakes, less than magnitude 2, on that evening. The swarm ended up diminishing. They said it might have picked up again, and they said that was typical of the summit repressurizing after the end of the last eruption. So I won't go through every little word, obviously. So moving forward, January 3rd, there was an earthquake. It was a 4.0. That was that green one on that map I just showed you guys, that occurred 12 miles below sea level, 4 miles northeast of Volcano. In that area, that's the adjustment zone between Maunaloa and Maunaloa and Kilauea, I should say. And in the vicinity of some of the deep magma sources of Kilauea, but no evidence yet that was directly involved, but that's curious to note that that's that same area. That was at 3:30 in the morning on January 3rd. So the next update was that following 8:55 a.m. And at that point in time, they noted a more general update that the last week saw variable seismic activity in the Kilauea summit region, with occasional periods of heightened seismicity beneath and surrounding Maunaloa crater, including a small earthquake swarm. They go back to the 30th here. They note another small swarm began late yesterday evening, January 2nd, and it's continued into this morning. That was January 3rd. And that does also add to that 4.0 earthquake that occurred. At that point in time, there was no obvious effect on volcanic unrest, but we would see that a couple of days later, that would be part of the sequence that preceded this resumption of eruption, Kilauea summit. That's the important stuff here. Let me skip ahead and just show you what happened next. This is the Uekahuna seismograph for the last 48 hours. So it's showing back to, this is the evening of January 4th. So things were pretty quiet still on January 4th in the evening. You still have occasional earthquakes, but here in the morning of January 5th is when you start having these more sporadic, but still increasingly frequent micro earthquakes. That's these vertical line splotches of ink occurring more and more as we go along. And then right in here, if I zoom it in, you can maybe see the time there. That's 3:30 p.m. So right before that, you start seeing the ramping up of this activity more and more. That eventually is going to lead to an eruption around 4:30. That's right in here. And you can see that the pattern of ground shaking, now this is what we call that harmonic tremor that you see all through here everywhere, where the ground is just vibrating from the fluid lava coming out of the pipe. And this is something that's been described in the past, like almost like blowing a recorder, right? You're blowing a fluid through some small area and it's causing a vibration, in which, if it's a musical instrument, it's something that's audible. In this case, it's something the seismometer can in this manner. So that's what the ground was doing, and these micro earthquakes are one of the most telling signs we're learning here for what the USGS is, how they're responding. So as soon as I saw that come up, they quickly raised the previous yellow / advisory alert / aviation color code level to the orange watch status there. So we went from yellow advisory to orange watch. That was at 3:20 p.m. on Thursday. They noted that it was not erupting at that point in time, that it was not certain there would be an eruption, but there was evidence of movement of magma in the subsurface, noting that an eruption within a national park away from infrastructure was one potential outcome. So not too long after that, 4:35, a little more than an hour, they noted the eruption had begun within Maunaloa crater, detecting glow in some image webcams. They bump us from orange watch to a red warning at that point in time. And they note that the opening phases are dynamic. So they're waiting to see what happens. You know, one possibility would have been that there could have been other fissures opening up elsewhere around the caldera floor. That's something that you'd expect to happen early on, and it has not happened thus far. So it seems less likely that it'll happen now. You never know, of course. And then coming to yesterday evening, issued a status report, still at warning red. And here we get a first snippets of data. They noted that the fountain, largest fountain, was consistently about 10 meters or 32 feet high yesterday, with bursts at 7:45 p.m. up to 30 meters, almost 100 feet high. And earlier in the day, bursts up to 50 meters or 164 feet high. So if you were there early in that late afternoon, early evening part of the day, you may have caught these largest bursts. Otherwise, if you're there slightly later, maybe you caught these slightly less, but still large bursts. And otherwise, if you're going more recently, you're seeing something in the order of only 30 feet tall shooting up there across the distance. Still massive fountains. Might look small because the landscape is so massive there, but really impressive stuff. They noted the area of the crater floor here, and that as of approximately 7:30 p.m. last night, about 10 meters, 32 feet depth of new lava have been added to the crater floor. They note tilt switched to deflation, that tremor resumed, and gas emissions had resumed. So that was the status overnight. They continued to assess overnight, and this morning, on further assessment, have decreased our alert level from red warning. We're now back to orange watch as of this morning, 8:15 a.m. And that's because the initial high effusion rates were declining, no infrastructure was threatened, and no threat of significant ash emission into the atmosphere outside of the closed. So that is the long and short of the updates here. Just re-show this image that we had put out yesterday, showing geologists there on the edge of Summit Crater taking measurements already and working hard to put out all this information. So mahalo to those guys for sharing, putting out all this data that we can then piggyback on and explain to you guys as well. So that's the updates. Going to the visual part of the eruption here, what I thought I would do is I'd first want to play back from last year, 2021, how that eruption began. It's going pretty fast, but you get the overall picture. The crater floor has been filling. Went from a large area of being covered in lava to a small area of that persistent lake with occasional ooze-ups around the outside. That's what you were seeing in that quick sequence there. I'll maybe let it run through one more time. More time here. See, it flashes across that whole crater floor, then retreats. In this case, it retreats to this western side, and that's where it focuses. But the entire time, lava is injecting underneath this bluish crust area, and this whole background blue area has been lifting and rising up like a big souffle or a muffin top. So that's the interesting aspect there. And this thermal image ends here on Christmas Day. So not quite a couple weeks ago here. And what you can see is lava had actually just paused on the surface. And in the interim time, we had noted on the V1, this is the V1 camera, had been repositioned to zoom out and see more of that crater floor. So there's that view we were showing last week. This area over here on the right is where that lava lake used to sit, that most persistent one. But just over here, left of that, on the eastern side, the far side of the camera of this central island here, this high ground in the middle, is where we were seeing that spot of persistent glow. And they're pretty much unwavering for all this time of pause that the lava lake has experienced. It's still been glowing out of that pit, so we knew that there's some focus of activity there. Zoom it back out. There it was right in here. And I'll show you guys that frame of the start of the eruption, and there it is with the lava, and you can see it's actually very, very close. It looks like the actual glowing spot might have been just to the side right here, and there's lava shooting from that area as well, but slightly further over to the right, to the southeast, it seems like that other pit that would also glow occasionally was the easier source for the main pulse of lava that burst upwards there. So that's how it began, and in this image, you can maybe outline it a little easier, see the outline of the first lava flow that burst out and started spreading across the crater floor. So the initial fountains were quite vigorous there and spreading quite rapidly across the crater floor. So to illustrate this, let's bring up this Twitter video from Janus Way National Park Service. Let me see if I can get it centered on the screen here. And I'll have to restart it here, but this is looking from the Kanakakoya overlook. So we're on the southern side, and there is that high fountain. And note the flow front here, something you can zoom into it more. See that it's almost like a tsunami front there, like a big surge of lava, big wall is just flooding across the landscape there at the beginning. It bursts forth and out. That's really impressive, and that was that most dangerous phase of the eruption right there, when you have actually looks like waves coming across. And some of these zones in there look like they're like a little bit wavy going across. Really impressive because of the earthquakes that were building up ahead of time. It seems like the USGS and Park Service and some of the other staff were able to mobilize, and either that or are very lucky to be there in the right spot to catch this really amazing progression of that flow front, that first surge of lava. All right, so look at that longer, but just the time, let's keep going. So here is a view from a B1 camera looking across that whole crater. So the central island is way over here, and we get a lot of this eastern side in the foreground. And I'll play this. So you can see that back over there, it's that zone of fume. There's eruption starting, and very quickly there's lava right in front of the camera here. So it circulates and covers this whole eastern part, which is the field of view of this B1 camera. And there's all kinds of stuff happening. You can see the fountains back here in this area. They seem to actually begin, I'm going to zoom in a little bit. They begin over here, closer to the island. But they come up next to this hornito here. They come up a little bit over to the left of the view from this camera angle. And as the image continues, that island fountain seems to die off, and we're left with the ones over here in the southeast quadrant. That's fascinating. That's something we'll continue to track, and otherwise you see big floods of lava coming everywhere. There's some other spots of fountaining over here on the right side of the view too, but it's kind of hard to see from this angle, so we'll leave that. But I did want to pull out this little clip here, and all I've done is zoomed in, and let's let this start again. But there's a little islet, a little island here that forms directly over this hornito. So there's a hornito, and as eruption starts, that thing actually bobs and seems to dip down, gets flooded with lava, and then seems to pop back up. And I remember that this little hill is attached to the crater floor, so this is probably, or possibly at least, reflecting that change in the crater floor itself, because we know that crater floor is crusted over. There's lava underneath it. The lava underneath it had built pressure. It popped up like a big boil, and once it happened, that upper crust sagged back down, flooded over that sagged area, but then continued to rise up from below and pushed it back up. It's almost like almost flapping up and down in that manner, right? So that was just did it a couple of times here, but as a result of having that anchor spot in the middle of that moving lava all around it, it does anchor and lava freezes to it, and it creates that little island there, a little islet that we see later on. So I thought that was really fascinating. I thought it was a really good illustration of how deep the lava actually is. We've heard that these spatter cones here and hornitos on this eastern side of the crater floor are in a range of 30 feet tall, something like that, right? So when you see the lava at times seemingly splashing over it, and then you see it emerging above it, then it gives you that same ballpark figure of 10 meters, 30 feet tall there. And really interesting and really cool. Hope everyone can see that. I hope I slowed it enough. You can see that drop down and then back up. It's pretty cool. Pretty cool little details there. So it's zoomed way in, might be a little pixely, so that a little bit, and more obvious to see that little curtsy, a little bob it does right there. So that's from the B1 camera. On the F1 camera, which has since stopped transmitting, but did transmit the beginning of the eruption here, we have this sequence. So there is that central island area here. That old drained persistent lake is right in here. Just at the very end of the sequence starts showing a little bit of red coming up in that same spot Dane mentioned, that eastern spot that we've had crust overturning in the past, but also where that lava tube, one of them was over this way, feeds back underneath the crust. That was where the lava circulated through. But what you can see from here is that there is that eruption site visible starting off as that initial outburst of lava. There's a second spot that emerges up here, and you can see at the beginning of the flood it's not there, but as the pressure migrates across the underside of that crusted crater, it seems to pop out through some weakness over here in this area as well. And that's similar to what we see in other areas as well, where we see other fountain spots develop after this first one over here in that eastern. So that's how it looks from the F1 camera. And to give some context of where this might actually go, I thought I would pull back the beginning of the 2021 eruption. So here is September 2021. How that began, you can see there's that central island, fissures just on the eastern side, very similar to now. You can see a whole bunch of them, different ones there. There were some closer to the south, some closer to the center, but also there was this one that formed here in the west. And ultimately, there was a west vent that took over, and the central ones ended up waning. And we never know if they shut off completely or if they just start trickling into the lava lake from beneath and mix into the lava underneath the crust without any surface expression. It seems less likely that would be the case, but really, you only see lava coming through the system and coming out from that west vent moving forward in time from this 20. So the other thing you can see is lava actually was covering the entire crater floor, which at that point was a smaller area because it was a deeper inset in the ground. But it did that for close to a week. It was covering that entire crater floor there. You can see here this is October 5th, 2021, it starts to segregate into different branches here, and it's starting to emerge islands from the middle once again. But that was a week into it, and here we are. We just showed you guys. I'll put it back on the screen. View, let's reload it. Maybe it's getting a little darker, and we'll get a fresh image here. Oh, no, that's the... Yeah, here we go. This is it. So there is our view of McKinney camera right now, and we can see that we have already had the lava that was completely surrounding the central high spot here, now retreating back to the eastern side, right? So it seems like we're already past the peak. And it might be because we have so much bigger area for it to spread across and flatten out as opposed to before where it was deeper in that pit. So that was the beginning of that eruption. So let me play that the full sequence of the 2021 eruption. You can see how that crust eventually hardened on the eastern side. This was the old north vent, actually, from that first phase from December 2020 eruption. Actually, the northern west vent, I should say, the north vent was over here. But eventually, you can see by mid-November 2021, it had retreated to just one side of it. That's about how long it took. So we're in an accelerated pace for that here. So looking at some other cameras, this is the S1 camera that came back online today. Or I'm sorry, last night, sometime 10, 11 o'clock at night there, and it's still online today. So we're now looking north is that direction. That central island's over here. That's the edge of it right in here. And that first fountain that comes up over here, and then the fountains eventually migrate to where the current live video is showing them in this area over here. So the current, most recent view is over there, but here that loop to the beginning again. There it is. There's that initial fountain, and then two more. There and there. This one over here dies off. These two stay strong, but you now have two more ones popping up over here further to the east. So a great angle to see the progression of these fountaining sources here. And remember that this whole crust that the lava is coming through is covering more lava underneath it. So it's really a crack down somewhere in that underground area that's coming up through the lava, then through the crust, and through more lava at the top. Really fascinating stuff. The other good thing about this view from the S1 camera is I can zoom it in here to the back. And into the night frame, but back in here is that lowest edge to that next down draw block. So people have been wondering, has the lava filled up to get to that next spillover area, and not quite yet. But you can see it's getting close. There is that lip right there where it's likely to go over right in there. Not that far, depending on how much it can pool into that particular area rather than elsewhere around it. We'll wait and see if that happens. I did have a question from a friend in Puna asking if the lava had come back to the same levels as it was before the 2018 eruption. And the answer is no. We have, if you look at the elevation of it, it's come up 70% of the way to where it was before. But because we have such a big wide funnel at the top, we're only more or less at 30% of the lava volume that we had in 2018 prior to that eruption. So 30% of the way there to refilling what we lost is another way to put it there. We're not close yet, and that is why we're seeing so much concentration of activity at the summit and really no involvement of the rift zone for some time. That's this current view of the current eruption S1 camera. I did put this together, which is looking at the S1 view from 2021 eruption and then putting the 23 eruption next to it. Now this is two slightly different angles, and it's looking deeper in a pit and then shallower in a pit, so you got to take all that with a grain of salt. But it's just trying to show a little bit of how from this point of view, there's that central island. You had on the east side similar kind of fissuring, fountaining sources. In the case of 2021, it migrated to the west vent, but in 2023, it seems to be migrating over to the southeast, at least so far in day 1. Day 2, that's what it's doing, is focusing on these southeast areas over here. I thought that was a pretty cool comparison. And one last view, here's the V1 camera for the time that it was positioned at that vent next to the island. This is the edge of the island right here. So there it is, and it seems to wane and fizzle out, and that source is likely feeding underneath the lava lake to one of the other bubbling areas now, rather than trying to put everything in at the right area so it makes some sense. So now we can come to this KW time lapse. This is the time lapse since the eruption began from that widest angle camera we have. And this is what allows us to see really the most detail of what's happening. So this is that view I just showed you guys, the sunset shot that's not in this animation here, but let me come in and start zooming into this. And so here in the center is that central island right in there. And it'll loop back around here. We'll see the eruption start back over here and spread out to the sides and wrap around. And then afterwards, you see, I just wanted to make sure that this is on screen. Let me get the screen here. The central pit, that persistent lava lake, there is that area of the lava tube right there. See, it's glowing. And maybe if when it comes back around, you see when it starts filling with lava, it fills from that side over this way. Right, that's that east to west opposite. And then afterwards, you see pop open. This is that west vent pond area right there. So after the lava comes back across this lake, you see it pop up and spill over from that west vent pond, which is still bubbling and spilling over for some time after that. And not only that, that previous eruptions, that northern west vent 1.0 we used to call it, over here, it also reactivates. See, the lava comes up through it, through the crust, and then through that. Likely the reason they're reactivating is because they're piles of cinder that are encased in different lava layers. So they're less dense and they float, and they're a weaker path for lava to push through, right? It's easier to push through a pile of cinder than it is the actual solid rock. So it seems like with the pressure below coming and filling, really what that's telling you is that as much lava is getting out onto the surface of the crater, there's still enough coming below that surface of the crater to actually push back through, to reactivate the persistent lake, to reactivate the west vent pond and the west vent itself, and that old west vent 1.0, this previous eruptions west vent over here. That was one of the more fascinating details to see, how it pops up as it comes across, pops open right here next. There it goes, and then same time over here. Pretty fascinating stuff. And that helps feed the flows that come across to underneath this camera on the western side. And you can see that as an animation goes on, those flows have still come all the way around. They actually came all the way around and met. So this is all fresh lava over here that's cooling and hardened. But by now, you're only seeing overturning of this lava ponded area, less so than lava being fed into it from the actual bubbling sources over here. So that's quite a lot of what you can see here. There's one other area I wanted to focus on that's hard to see from most other angles, and that's this very northern corner up here, right in here. There is a sliver of this old collapse zone, like right in here, that's a little bit higher than everything else. Maybe this is it right here. Hard to pick. Oh, there it is. There it is right there, that little spot right there. That's a little bit of an island of the old rubble from the 2018 collapse. So that's the only spot not covered. Everything else, you can see lava floods all the way around, all the way to the edges, all the way around there. So there's some other flows that keep coming, and you can see the hoi hoi coming over top of this later on, and you can see overturning down in this area down in here as well. But it's really that initial burst that really changes the shape up here. So when you're looking at these maps and the shapes of the lava at the crater and what looks different, what looks like it filled in more, it's this area right here in particular that's the one that's the most noteworthy in here, especially, right? This whole northwest edge was filled into. So now that that is noted, I just wanted to show a couple of images here. This is from the USGS this morning on our 6:45 a.m. overflight. You see the sunrise just hitting halfway up the slopes of Maunaloa. Maunaloa eruption site was more or less in here-ish. It flowed on the other side of the mountain, away from the point of view. And here in the front is Kilauea and reverse angle. So there's our central island. There's our persistent lake behind it, and our new southeastern vent cluster, and flooding that whole eastern side of the creek. Here, if I were to zoom into that area, that's the one I was just pointing out. That's that new edge that got filled with lava. Right in here, this must be that spot that's not quite covered yet, that one little island of old collapsed rubble. So that is how it looks from the air. Show you guys the map next. So this map, more of it, screen. Map was released today, and it's showing just the changes that we've had since this resumption. So yellow is that crust from that previous phase, that we'll call it from last year, and the lighter pink color is where the lava ran over during that first phase that we just saw yesterday, and that's that area here that I was just pointing out that changed a lot, that northern tip there. So there, and red is where it was still active at the time of mapping. We've since seen that maybe this has retreated even further from when this map was made earlier. The vents are noted right in here. There they are, eruptive vents, the little cluster of orange dots right in here. So there it is. And when we talk about it spilling over to the next ledge, it's this area right along here, and that ledge area would include this whole part of the crater floor. So it gives it a whole bunch more area to fill into and spread out. It's already a huge area, but it gets even wider. And that's all still a collapse of 2018. It would have to refill to recover that lost volume. So still 30% of the way there on those terms. All right, so that's there's some stats on here, but let me just skip those until we have more to compare them against. Just show you what it actually looks like from ground level, more or less. This is a USGS helicopter overflight clip when they're skimming down over that down drop block area, looking across the lava lake. So there's a central island, there's that high darker spot in the center right there. This right here is a cluster of southeast vents that's still spattering and feeding this lava lake that's crusted over and looking silvery with just the red and orange glowing between the crusts. This spot here in the foreground, that's our little islet. That's the top of that tornado that we saw bob up and down right in there. And you see lots of steam and gas coming up everywhere as well. So really to get that view from the US there. But since most of us are not able to fly in the USGS helicopter and get this kind of view, like where can we go and see? This was going to be what we talked about next. Here's a map of the national park, Kilauea Caldera, Kaluapele at the center here. The entrance station is over here in the top right there. So when you come in, the first area is Volcano House. There are some views from Volcano House of some partial parts of the crater floor. That's really true everywhere. Everywhere that you go, you can only see some part of the crater floor, not all of it. Down in here is a pit where the lava is filling right now. And as we've been pointing out, the lava is now more so on this side, like that, the active lava, but it's still glowing and visible elsewhere as well. So from Volcano House, you can see more of the backside there, so including that persistent lake, which is still visible. And also from Kupina Ipali, also known as Waldron Ledge over here, a little bit of a walk from the entrance station, about a mile, but all paved and wheelchair accessible. From there, you can get a view as well. It's slightly better because it's slightly lower part of the bowl there, so you get a better angle looking at. We'll show you some examples here in just a minute. So that's that eastern side, Kupinaipali. Kanakakoi showed you that one video already. That's down here. That's that closest view, but it requires a mile walk-in from that farthest parking lot, Devastation Trail. Kanakakoi Overlook. And the one that's the least walking, 200 yards from Uekahuna, or 300 yards from Kilauea Overlook, is the Uekahuna Overlook by the old platform that's a signaling platform, and that doesn't see any of this side of the crater, but it does see everything over here. So you can't see that central island directly, but everything that's happening on that eastern side is visible from there, and it's also easy to. So
also,
those are the 3 sites.
Also worth noting on that one, on the Kahuna one, and over by Jagger Museum, that there's areas that are closed to nene nesting, and to check with the Hawaii National Park if you're planning to go over that way and try and get past Volcano House or past Jagger Museum or anything like that.
So I had read that was actually reopened since that happened. Well, that had changed. However, I haven't been up there. The area that goes to the actual, if you're in a parking lot facing the crater, most people would usually go to the right in the pass. That's the high spot. It gets not a direct view into the crater. That area is closed.
Yeah, it says while the park remains open 24 hours. Oh, sorry. What was that?
So if you're looking at the crater, what you're going to do is you're going to go to the left. If you're facing the bathrooms museum, you're going to go to the left towards the Kilauea Overlook, and that's the area that has been reopened since it was that area was all closed for a while as well.
Yeah, it's the west stuff that's closed, and the parking lot there that's closed, and yeah.
Yeah, right. So there's people up there parking, so they can direct you. There's signs, and so just follow the guidance from the rangers there. Yeah. Pretty obvious once you're there. So we did mention Kanakakoi. Here's another image from Kanakakoi of visitors looking at that lava lake last night. This is from National Park. There's some idea of what it might look like, that whole bowl filled. From Waldron Ledge, we're going to share some highlights of 2 pineapples. So also coming in and streaming up there. So there's a view. You can see that whole central island surrounded, lava on all sides. And you can see that bubbling source that's closest to the island is what you can see from that point of view. And a secondary one over to the left here. Over time, we've noted that this one over here, the central one, actually dies off. And now it's that one on the left that you'd be looking for. In this earlier first phase yesterday, they caught some really nice fountaining, big flows coming around. Let us play a little bit just so you can get some different views, right? And worth noting, they have some nice lenses. They're zooming in, so definitely bring a telescope or binoculars if you can, or a big camera lens if you have it. Yeah, some really different kinds of bubbling, more bursting, and you never know what you might see when you get that. So this is once again all from Kupinaipali, Waldron Ledge, and mahalo once again to Pineapples. Appreciate you guys. And I myself went to station at Uekahuna, and here's a view across 8 p.m. last night, 10 p.m. last night, and then 8 a.m. this morning from Uekahuna. And you can see that the crust is moving less. There's still some fountaining sources there, and I'll have to maybe zoom it in so you can see it. But in this first phase of 8 p.m. last night, clearly see 2 waves coming together, like as a central zone where there's 2 fields of lava are meeting. By 10 p.m., that's no longer the case. Everything having been focused to the southeast vents. Right, but maybe I'll zoom it in so you can see a little bit more of these different patterns. And this is sped up a lot, so this is not what it looks like when you're just sitting there. You have to kind of really notice the details, right? There's our Hornito islet with lava streaming past it, bubbling earlier on here, and you see how many more bubbling sources there were last night, and as time goes on, you can see the crust gets harder. There's less movement, and still a whole bunch of sheet of lava moving in this morning. And zoom it into the fountain sides of this morning. So from Kupina-Ipali, we're not seeing. I'm sorry. You actually could see that central island and that fountain. So we don't see those. Those are off to the right here. We're missing that big one. But these two other ones that were larger that you could not see from Waldron Ledge Kupina-Ipali were the ones visible from Uikahuna. So interesting how that works out. You have to be of all the different sides to see all the different parts of it and see it all from any one spot. So either you pick one spot that you're happy with, or you're planning to go everywhere and you're going to do a lot of walking. And that's epic. That's even an option to do that. So much fantastic viewing from every side of the crater. This is what we've been talking about for years. Better and better viewing as lava fills in the lava stadium, and the higher it comes up, the more places you can see it from. Really cool stuff there. So that's the viewing. As far as air quality, we do know there's fog coming out. However, in a national park, everything has been in the green. Been no issues. You can see over at Kahuku, over by Ocean View area, there's a little bit of SO2, but that's not by the viewing areas for the national park. Eruption site now, so everything's looking good there. However, we do know this is the KP camera from last night. So up on the slopes of Maunaloa, looking down at Kilauea caldera, Kaluapele is right in here. And you're seeing the glow from the eruption, and you're also seeing this gas cloud. So we know that there is some atmospheric impact here. There you can see it. However, we don't have a measurement of the VOG volume yet. Therefore, the VOG forecast isn't very telling yet. When you do load this the first time, let me get a fresh load here. It does say Kilauea is erupting. Air quality conditions may change rapidly, but they still don't have a good input value. They're still looking at 153 tons per day as their input value, and so it's not showing much VOG. The true number is likely in at least the several tens of thousands, right? So it's going to be a lot more and wrapping around here, and more than the map is going to show right now. So this is when we like to pull up our citizen science tools. Here is purple air, showing a little bit more of where there is pollution on the island. You see some along the Kona coast, some in South Hawaii as well. Of course, as we noted last week, we're looking at our background levels. This combines all different sources. It doesn't tell you where it's coming from, but does tell you we're not seeing anything red here yet, right? It looks like Naʻalihu Ocean View might be getting some of this VOG coming from Kilauea, but still at yellow levels there. So VOG is the main hazard now, since the lava is not going to use any information. All right, so looking at monitoring now, this is on Kilauea at the lava depth for the last week. So it had been flat, and here it is when that pit where the lava is, where the laser is pointed into, full of lava here. So it goes from 366 up to 374. That's 8 meters within that pit. We're hearing 10 meters across the rest of the crater floor. We did note that there are some areas that are not covered in lava, so obviously it's variable. But that's the actual data we have to see right here. And there is how it looks in the last month, where it had been flatlined for now. It's bumping back up here. On the tilt for the last week here, we see mostly the eruption pattern, which is this up and then down here as well. However, there is a spike going downwards here, and that's part of the sequence I didn't mention yet, is that there actually was a 3.7 earthquake that occurred on the 5th at about, I want to say it was 2:30 p.m. So about an hour before all the, it was part of that building sequence of all the little earthquakes, and then microseismicity, and then eventually tremor, right? But that was all seemingly following this 3.7 earthquake that was underneath the summit right there. So that caused a little tilt spike, and then that resumption there. And there it is for the last month. So there is eruption signal following this gradual inflation all month. GPS is still not showing us anything different. There is north-south still expanding. We'll have to wait to see. This takes several days to come in and adjust, so too soon to really note there. But minor change on the east rift zone line. There's like a little bit of a turn there within the range we've seen in the past, but possibly that was related to the eruption building up pressure to burst through. So would expect this to continue its trend, even with these little wiggles that it's shown before. So continue keeping your eye on that. SO2, we have no new measurement yet. The last one is from pre-resumption, still down here in 150 tons per day. So this will change entirely when we get that new point, and all these will squish to the bottom. And for the last year, here we are, had been decreasing for a while, and now it's going to jump back up and likely for a while. So 1 month earthquakes. Here we are. This is our bucket of day right here on the very right. So this is the drop that we're looking for. We saw the cycles of increasing seismicity and then persistent increased seismicity there. Not at crazy levels, but you know, it's a weak system, so that was enough for it to pop through. And once the earthquakes peaked yesterday, today has been a lot less earthquakes on Kilauea. So that's the only place you can see it so far, since it's really just today, it's so recent. Not showing up yet over the last year in earthquakes per week, or in the last 5 years if you. So there is that graph we started off with, 1 week on Kilauea, right there. If I scroll it back to the whole last month, then it's a little bit more alarming if you were to look at just that and hadn't been watching. You look at what's Kilauea been doing the last month, and when you see this, you're like, oh wow, there's really some pressure building under there. And so not really surprising, talking about this for a while, as the pressure was building deeper under Kilauea, response to Maunaloa's build up and then relaxation with this eruption. So those are our Kilauea signals. Maybe let's give one refresh here to the webcam page and just do a scan through the webcam images. So there's our KW camera following that pattern we laid out to start. Our F1 is still not putting in data. This one is the V1 camera that's now focused on those bubbling sources there. So we'll look at the live camera here in a second as well. From the B1, nice wide view of the lava lake there, still glowing and brilliant through the cracks on this whole eastern side that this camera faces. And some of the other views from the tower up the area where the Nene are close to. This is a kind of view to get anyway. So you don't really get into the glowing crater wall there outside. So there's, and there once again from current webcam views. So we haven't missed anything that happened unexpectedly while we were live here. Let me pull up the live stream one more time. So there's another live look in. And we're not done yet, but I just wanted to kind of make sure that Kilauea didn't sneak by us quite yet. So let's look at earthquakes real quick. Here's earthquakes for the last day. And you can see Maunaloa, there's nothing at all. Kilauea, there's a few, but not nearly as many as we were seeing the previous day. So still a few. It's expected you see some adjustments, but not very many since you have an exit point for all that pressure. So those are the earthquakes. Before we wrap it up here and turn to the questions, let's do a little bit of Maunaloa just to show, rather than just say that nothing's happening in Maunaloa. I'll show you guys what's actually going on there. One thing to note is this image was released by the USGS. This is comparing the Mokuavo Ve'oveo Summit caldera there earlier in the eruption in November when it's all filled with lava, and then a few weeks later with big ice deposits there covering lots of that crater or some of the eruption site. So all quiet, getting really cold up there, really cooling off on Maunaloa from the weather and lava flows themselves as well. There were a couple images released last week here for Maunaloa, and here we see the geophysicist with Mauna Kea in the background here and snowy Maunaloa area collecting GPS data. There was a GPS survey that was done following that eruption, so they're doing like a post-eruption survey here. Another one of those GPS on tripod that was iced during a recent Kona low storm. no damage to equipment, everything broke away easily, but part of that sampling effort that was put forth. So I'm sure we'll, in the months and years to come, hear more about Maunaloa with the status. As far as the USGS update, the most recent one was yesterday here, and it's still at yellow advisory, not erupting. No signs of activity from the webcams. So I'm not showing any webcams because there's really nothing to see. We showed some glow from the flow front last week, but it's not visible on webcams anymore. It could be visible by the naked eye if you happen to be driving through there or parking and looking and that kind of thing. But really, it's continuing to cool, having released all of its pressure. Right? Maunaloa built up pressure, released it through its flow. By releasing that pressure, allowed Kilauea to then lead into it further. So Kilauea would then build its pressure, but did not release it. It just kept building it more and more and more, and now it is releasing it finally. That's how they all fit together. No seismicity, no tremor. They're still monitoring, but there's really nothing else to show here. Looking at the monitoring signals, here's tilt. It's showing just daily signals and a slow, gradual, very weak inflation here. That's the normal pattern. Sometimes we see this pattern as part of a longer cycle across a year. GPS, similar, still showing some extension following the eruption. But that is a typical pattern that you see. It's happened after 1975, after 1984. And those are the only places we have data. We're getting here a bit.
Can you hear me?
And if anyone has issues, can get this. Dane, are you still with me? Keep this rolling here. Oh, testing.
Can you hear me?
I can hear me. Hello. Apologies if anyone can still hear us.
Hear me now?
Yeah, I'm still,
Oh,
I still hear you. I don't
Hello?
think you can hear me.
Can you hear me?
Yes.
Yes. We were disconnected there for about 2 to 3 minutes.
Are we still rolling? Should I cut us off or what's?
I don't know. I'm trying to figure it out now. If there's I think it's frozen. Oh, we might be back. I think we're all back.
All right, perhaps.
Yeah. It was
Apologies for
going
that,
so well
guys.
until that. All right. Are you still there?
Yeah, I'm still here. Yeah, I'm just
All
really
right.
just waiting to see if we're gonna get some response and keep apologizing. It was pretty much through the presentation here. I was just talking about Maunaloa.
Yeah.
Following that same pattern as post 75 and post 84, still looking normal, no earthquakes, and really that's what I was gonna there. So
think
if we
we're-
are indeed back on,
Go through it. We just dropped about half the viewers, but that's fine. Yeah, you guys get a special little treat at the end. We're sticking around.
all right. So we have a couple questions.
Oh, we ready for questions?
Questions
All right.
or thank yous?
Yeah. Let's get some thank yous in. We did have one super chat, I believe, from Taiwan, our Taiwanese friend. Yes. Wait, let me try the name again. Jing Bin Ying, 300 NT super chat. Sorry for butchering the name. May I ask whether the volcanic eruption can ground fissure? I believe that would be an indication of like a fissure happening outside of the caldera. Would be my interpretation on that. There is a language barrier here, so
Yeah, so I mean, there are fissures that are there, but they're likely underneath the lava, so you don't really see them as clearly as you would otherwise. And the area that collapsed in 2018 is the area that's the weakest for the lava to come back through and break the surface as a fissure. So it's possible that the fissures would have not stayed only within that inner pit, but it could have gone elsewhere inside the caldera as well. We know that fissures like to work up crater walls, so it could have actually gone up the wall of a crater and then across the wall and be able to put lava into the main caldera, for example, if it had actually cracked up that high. But that does not seem to be what happened that we can tell. For it to go further away from the caldera, from the summit regions, you'd expect there to be buildup of pressure in the rift zones, for example, with more earthquakes, ground tilt, those kind of signals, and that's what we're not seeing, and that's why it was fairly easy to say yesterday that once it popped open at the summit, without having even pressurized those other parts of the rift zones, that's likely to stay at the summit region and not be a threat to us. That was really the key part of it there. So yes, you could have a fissure elsewhere in a caldera. That still could happen, and that would have been interesting. We've discussed in some of our videos how they call an eruption the same eruption or different eruption if it's in the same place or a different place or close enough in time or far enough in time. And maybe if it had opened up far enough away, like in Kilauea, you would have called it a different eruption, right? But because it happens to come up through the old one within that 3-month window, that's the arbitrary window, then it is called the same eruption. And even if it has new fissures, that we can't see is still the answer.
Right. Well, let's appreciate the donation. Hope we answered the correct question there.
Hopefully,
we have another
it.
question.
Yeah.
We have another question from Greater Good who asks. So we talked about it returning to the height of the 2018 level, and it was only 70% the way there. But remember that 1 month ago, or probably 2 months ago now, where we had that drop in the level of the lava lake at Kilauea. Has that been regained? Is the question.
It's hard to say. It's hard to say because there was one measurement reported. It looks like they measured it on December 29th, maybe, but there was not a map output there. They just mentioned that the crater floor had come up 1 meter from the previous measurement back in the end of October. So I want to say that the drop was more than a meter. It was maybe a little bit more. So it came to, it recovered some of it, but not all of it is what I feel happened there. And towards the end, it seemed like it was just getting less and less and less and less was coming out, that it was really it wasn't accomplishing much towards the end there as far as regaining that volume. But maybe we'll get that compilation map that compares December 29th to January 5th here at some point. Yeah, good question.
I have a question, and I was hoping somebody was going to ask it. I'm just going to say 2 pineapples asked it. The question is so we saw in the previous eruption how the surface of the previous lava lake was rising with the lava alongside it, and we were getting that floating island in the middle. Is there any indication that this lava, that the top is rising with this one, or is it just filling onto the top of it? Do you believe? Have you seen any?
I think that the video that we saw of that Hornito turning into an islet shows that the crust is getting pushed upwards, right? Because it actually sagged down to start, then it came back up, and then now the lava is still filling it in, but that islet's still at the surface and it hasn't been submerged any further. So that to me indicates that the whole thing is getting pushed up, as well as also seeing lava emerge not only from east of that island, central island, but also push under the crust and reemerge from that main pond and from really West Vent 1.0. That's pretty unusual and would suggest there's a lot of pressure underneath that crust to push it back up, right? The thing is that when that crust when the eruption paused and that crust essentially settled, it kind of got locked into the edges, right? 'Cause it's like the center part that rises and falls and the outer part doesn't. And so they kind of got fused by the lava when it stopped erupting as much. And now that it's repressurized, it's having to re-break that central part from the outer part once again. And that's where you're starting to see some interesting, cool things happen, I think. And that's where you might expect to see some changes coming forward, right? You might see more of those cracks opening up around that central area, and that central area rising more if it's going to. And then you could see ooze-ups coming up from those cracks as well. Now, you'd think that at some point, enough eruptions happen, that central island gets covered in enough new lava flows that eventually it offsets that buoyancy that it has, and it just gets covered more and more and more and more. So it might get covered a little bit more and not float quite as high as before, but it seems like it is still buoyant and rising with the small few clues that we're picking out from the webcams thus far.
Right. Bill has a good question here. Yes, if it's if we're talking about the crater there where all the previous eruptions have taken place, and we have this big old bowl of lava, liquid lava, how does that lava intrusion on the bottom emerge as a fountain on the top? That would seem to indicate that there's a solid or semi-permeable path of some kind to the surface.
Yeah, I think certainly, we don't really know exactly what it's like in that cooling magma body, right? But you certainly could have some more semi-solid areas that are slightly cooler. But to me, the real answer to the question, it's a great question, Bill, is the gas, right? It's like the gas is nucleating out of the magma down at a half-mile deep, so way down below in the earth. And it's the bubble of gas that's rising towards the surface, that's rising and expanding, which makes it want to rise more and expand more, and it keeps coming all the way up. So when that bubble comes into the bottom of the lava lake, if it's goopy at all, it's going to find a path upwards, and it might not be able to go straight up. It's going to come maybe up and deflect around some goop this way or deflect on some goop that way a little bit. So probably it comes up more or less straight in the area of where it's popped up, right? And the thing to remember is that, if you have a fissure on land that's not under a lava lake, what you often see is the crack has got areas that are wider and release the gas more easily, and other areas that seem to recycle the lava back into the crack. There's like a circulation that occurs there, and the lava drains back into the fissure as well. So there's some of that replacement must be happening there as well. But the other point is that the fissure has some length to it too. So it could be that all those bubbling points connect underground through some irregular shaped crack, and then some part of the crack gets more clogged, and so then it kind of focuses the bubbles out to another part of the crack, and it's coming up slightly other areas underneath the lava lake. That's the best guess that I can offer as far as a way to think of it for us to discuss. I know there's more out there that I haven't researched and read up on as on these semi-solid materials and how it all cools and how it might all go together within the lava lake. But that's what I can offer for discussion here.
All right. I think we'll come to a final question here. One from Chris asks, will the summit need to rebuild significantly before we see another rift eruption?
That's hard to answer, really. I mean, you'd want to say yes. Yeah, I mean, really, it's a good question. The thinking is good, right? I mean, and I've been saying exactly that the summit's so weak that there's so many paths out of it that it's unlikely that it goes to the rift sooner, right? The caveat is that the upper parts of the rift are really kind of connector isn't attached to the summit and are almost part of the summit magma system. So you can have an eruption from the upper East Rift, for example, say between Kilauea, Kilauea caldera, and Maunaloa, let's say, right? And one of those pit craters in the chain of craters road that the tourists will stop at. To have something happen in there and technically still be within that summit zone. And likewise, in the Southwest Rift, right, where we had an intrusion back in August 2021, that area, if it's far enough up the hill, could also be that Southwest Rift connector of the summit, right? And then to get to the next stage, those two connectors have their own connector that's called the Kauai Fault Zone that occasionally gets intrusions and even more rarely will have eruptions. It's also part of that whole summit zone. So all that is they're all pieces that can adjust before you have to push things into the rift further over, like to Pu'o'o and beyond, or out towards Kau, right? So it could happen that it rebuilds partially and then is able to find some of these pathways to work other parts of the summit, because it's almost like a big triangle, right? And so you're kind of wiggling it in little manners this way and that way. So you could actually move from one side to this, around a caldera, different parts of the caldera to adjust. And it might lean more towards the Southeast Rift or the Southwest Rift as time goes on here. So that's what I would put out there. I think if I were to, add something like before another lower East Rift eruption, then I would say I'm more likely to lean to yes to that answer, right? So Summit probably does need to build more and fill in more before we see another lower East Rift eruption. That is how I would lean.
Right. Well, I think that gets us through most of it. We do have a little bit of a schedule change for next week. I want to get through. We have the Volcano Awareness Month beginning next week on Thursday, and that's our normal streaming time. So instead, we're going to be coming to you live on Wednesday at 5 p.m., and then we'll be covering with Two Pineapples the Thursday presentation. That one is tracking active faults and ground deformation south of Kilauea caldera with Hilo's Geology Department. So we'll be going through that one with you, but we'll be coming to you Wednesday with another presentation on Kilauea, unless something crazy happens, and then we'll go live covering that beforehand. If something unexpected happens, then we will go live. But barring that, it will be Wednesday, 5 p.m. Hawaii Standard Time will be the next time we'll be coming to you live. And I do want to, also just thank everybody for showing up, being here. We rely on viewers like you. The likes, subscribes, the shares, all that stuff really does help the channel grow. And, basically it's trying to fight the algorithms of, YouTube, Facebook, and all those guys. So that really does help and, gets the thing put into people's feeds so they see it more instead of, the crazy hype, videos where it's not even Kilauea that they're looking at, type of thing. Did have a super chat wanted to acknowledge from Brad. He said, 1999 super chat. Don't often get to catch you live. Much mahalo for all you do. Appreciate the support there. Appreciate everybody that turned out today. And I think that gets me through it. Oh, I do want to shout out I Care Hawaii, helping us keep an eye on the Hawaii volcanoes, Maunaloa, but you got to keep an eye on Kilauea too, right? Because they'll show you that as soon as you take your eye off one, the other one starts moving on you. So yeah, we got to see where the lava's coming to get out of the way. So we thank I Care Hawaii for their support.
And County Hawaii.
Yeah, might as well. County of Hawaii, we would appreciate them as well. They're really helping us to keep these type of content going and keep the regular updates going. We're doing the video updates, these live streams, right? But we also have short videos that we post, and then we have the written updates that we really post on Hawaii Tracker on the Facebook group. So if you're not part of the Facebook group, you should be part of the Facebook group. And if you don't like Facebook, check us out on hawaiitracker.com, and we have our own in-house social media platform. It's very basic, but it gets the job done. And we post everything there in chronological order, so it's easy to find and go back and pick up the newest things that are being released.
And there's a Telegram channel too, that kind of thing.
Yeah, we are doing a Telegram channel now. That one is just Hawaii Tracker, all one word, on Telegram. And yeah, it existed, but it wasn't really used, and we started using it more with more engagement and stuff like that, and the Maunaloa eruption, and that's carrying forward. So yeah, that's the easiest ways to find us. Twitter and all that, we're on there too. But yeah, it's really the Facebook, it's really the hawaiitracker.com and the YouTube. Those are the primaries.
Thanks, Dane.
And I think that gets me through it, and appreciate taking the time to get all this laid out for everybody.
Yeah. I'm glad to throw in the bonus episode here this week. And apologies for a little bit of the issues we had there. Schedule challenges as well. It's always a challenge when information's coming out of a fire hose at the last minute to get it organized and in some presentable format and know what to put in and what not to, and that's not be here forever. So that's a lot of it there. So there's plenty to come in Hawaii Tracker over the next week. So if you're looking for the pictures, the imagery, the shorter updates, we'll be doing those. But otherwise, we'll see you guys next week at our temporary transitional time here, Wednesday, 5 p.m. And until then, from hawaiitracker.com, he's Dane DuPont. I'm Philip Ong.